Thanks, Andrew. So I'm Gopal Venkatesan, Twitter handle and GitHub handle G13N. That's basically the 13 characters between G and N. I'm a Yahoo Mail front-end engineer, and let's do a quick demo first so that I can talk about what we are really talking about. This is Yahoo Mail. I don't want to do a demo of Yahoo Mail. My IQ will fall short. So basically, you have the list of messages here for any folder, and here you have the list of applications. These applications are basically, basically add-ons on top of Yahoo Mail, which enhances the user experience. So that's what I'm going to talk about. How are we coming up with the next generation of these add-ons, right? So here's how the attachment experience would look like. That's my nice motorcycle, Harley Davidson V-Rod. And we are changing that to, oops, something like this, where you could do a nice hover and all those things. So that's about the demo. And oops, let me talk about it. Okay, so quick intro on Yahoo Mail. It is a fully fledged AJAX application built on top of the awesome YUI, YUI 3, and probably I can think of this as the largest YUI 3 based application, unless the YUI 3 folks can correct me if I'm wrong. And all of the entire application is built like modules, YUI modules, YUI.add style, you know. And one of the things that we changed as opposed to the classic YUI is that the dependency resolution is built at build time for us, so that we don't do runtime lookups because we have like hundreds and hundreds of modules. And the application extensively relies on YUI 3 event, base, and widget infrastructure. Okay, so what is a Tictac? So I was talking about add-ons, right? So the code name of Mail, Yahoo Mail, is Minty. So one of my friends, Joe, he came up with a nice name for add-ons, Tictac, because it can enhance Minty, fresh. So Yahoo Mail add-on is called as a Tictac. It enhances user experience. Examples I showed you: attachments, photos, calendar, and so forth, right? Okay, so how does the new Tictac architecture look like? Here's a quick overview. You have Yahoo Mail. You have a Tictac loader, which is a small PHP script, which is part of Yahoo Mail, but that does a lookup of the app config on the cloud. So we have our internal cloud engine running in, and this one reads up all the app configs from the cloud, and basically upon Mail launch, whenever the user launches Mail, it binds all the Mail core events to each of these apps. As simple as that. Then for each of the events, basically does a y.after of each of these events. It just invokes the loader of the app itself, right? Simple, pretty simple architecture. You would be wondering why there's a lightning talk for this. So here's how the app config looks like. This is for per app. So there's the name for each of these apps, and the URL points to the main file, which is main.js. The main.js in turn can have dependencies, can do a YUI.use, and so forth and so on. Then it also registers itself to the event for which is part of the Yahoo Mail. Yahoo Mail publishes some of these events on a global level, and one of the this is not the real event. I'm just giving an example here. ymail:"message rendered" is one of the events whenever a message is rendered. And live true basically informs our loader saying that whether this app is live or not. Basically, you could still have testing, Here's how it is deployed. The app config, like I said, dictates whether it's live or not. And whenever the developers, one of them is me, commits the code, there's a Jenkins job. We use Jenkins job, which actually bundles all these app configuration into a single JSON config and then pushes them off to the cloud, so that the next time the loader, which I was talking about, can read the configuration and instantiate the applications. right? So as I said, just reiterating, config reader, it just reads the application config from the cloud, sets up a nice YUI config for the app base because they live outside of Mail. Mail uses its own YUI config, and passes these app config to the JavaScript. And here's how the client-side code looks like. There is some nice YUI 3 sugar here, object.each, and so it just gets a list of modules which are basically for each of these events. So the mods by event looks pretty much like ymail, message read, app1, app2, app3, app4, some other events, say compose, app1, app2, app3, and so forth. So what this guy does is pretty much this. Y.after, event, and the loader. Here's pretty much the standard stuff of YUI.use of the module list and all those things, right? So that's about it. And the way the Tictacs are built are, again, based on widgets, because that gives us some of the lifecycle events, initializer, bind UI, render UI, and all those things. I don't need to talk about all these things because it gives a clean API for all of these widgets. And we use the attribute change for the UI updates. And that's pretty much about it. So in conclusion, what does this give us? We are not tied to Yahoo Mail release at all, because the loader actually loads the app configuration and the apps from the cloud, which is independent of Yahoo Mail, which means that I, as an app developer, sorry, it's not open to third party yet. I, as an app developer, can independently push my code to Git to the cloud, and then point my YUI base to that, and that's about it. So, and there is loose coupling between Mail and the add-ons itself because we are relying on event. We don't need to really say that, okay, I go for any app to be added onto Mail, I don't need to talk to Mail or modify the Mail code base. Independence. And because we use base and widget, it kind of gives us a very clean API. And faster development as well. Like I said, syntactic sugar. We don't need to check for has own property and all those things. We use y.array.each and all those kind of sugar methods. That's about it. Yeah. Thank you. Any questions? OK, thank you very much.
Next up, we have Stephen Murphy with Gear. So today I'll be talking about building JavaScript and CSS using Gear.JS. Who am I? Well, I'm a senior software engineer in the Yahoo search team. Been with Yahoo almost 5 years now. And what is Gear.JS? Gear.JS at the core is a blob processing pipeline. And what do I mean blob processing pipeline? Well, you can think of a blob as kind of an immutable string. And so the read method here will take these file names, read those files, turn them into blobs, and then each task will have this list of blobs which it operates on asynchronously. And once the task has finished, it'll go on to the next, and so on until the processing has completed, at which point the callback will be called for you with either an error or results. So what you see here is we're linting these files, concatenating, and JS minifying, and then we're writing the file out. So if you've ever need to deploy to production or build a file that is basically built from mini files and you want to process that thing, well, this is the module for you. So it's being used throughout Yahoo on various projects. I'll get to that in the next few slides. Some of the features are tasks are incredibly simply defined. They basically have an input as a blob and then an output as a transformed blob. And asynchronous execution, as I had mentioned earlier. Extensible task loading. You can load tasks from existing NPM modules, a file you have sitting around, a directory to load all the files, or an object currently instantiated. And this thing works in Node.js and the browser. So you may have a need for whatever reason to want to have this thing build files on the browser, which you can do. And who's using it? Shifter. Dave talked about Shifter this morning, and it is using Gear.js as well as Mojito Shaker, which is a compiling asset tool for Mojito. And some of the default tasks for Gear are reading blobs, writing blobs, concatenating blobs, meaning let's take multiple files, put them as one, and then this tasks task, which I will get to later, which supports asynchronous parallel task running. And then GearLib. GearLib is where you'll find all the JavaScript and CSS modification support for task running. So JS minify, JS lint, CSS minify, CSS lint, less. It'll compile your CSS less files. Replace will replace a string in your blob. Let's say you have a little, dollar time, and it'll fill that in with whatever you want. It's very, it's basically like string replace. And then glob is wildcard file loading. So you can say load files star.js, and it'll find all the files in that directory. And then S3, you can deploy your assets to Amazon's S3 service. And so how to get started using Gear.js, you can npm install gear-lib. And this is what it's going to look like to build and deploy to a CDN. You're going to read all those JavaScript files, concatenate them. JSLint, we'll use nomin in this case, and JS minify, and then we're calling S3 here. And so we're going to write this foobar baz.js file out to S3, passing in our key and secret and what bucket we want. And if you're trying to debug your queue, you can call the log task, and that'll spit out a string where you are in the processing. Inspect will output all the blobs in the queue at that point. And this is kind of one of the more advanced aspects for Gear.js. What this is doing is we're running tasks in parallel that operate on blobs, and we're going to join their results. So we spit out basically into two paths here. We have we're reading the foo.js file, and then tasks will basically set up a split node, and then we will process on one node. We'll read, combine, minify, and we're going to print. And then in parallel, we're going to log, and then we join at this bottom node the parallel and print tasks. So you can do a lot here. Basically, it'll support the most complicated build setup you can throw at it, and it's been proven in Shifter and Mojito Shaker. So hopefully you'll have a use for in one of your projects. And if you want to find out more, you can go to gear.js.org. There's a lot of demonstrations on how to use this thing. And you can actually run the examples on the site. So I had mentioned that there is browser support, so you can run all these things. And the files are coming from local storage. So give it a shot, and hope you enjoy it. Thanks. Okay, thanks.
Next up is Leo Alvarez with Mjata Charts.
Should there be? Sure. You can just come up there. All right, thank you. Okay. Hi, my name is Leo Alvarez. I'm in the finance group, and this talk is about our new version of charts using HTML5 and to replace our current existing charts, the interactive charts, if anybody's familiar with the finance site, that are written in Flash, which I also happened to write a long, long time ago. So here what we're doing is actually using HTML5 canvas for the finance charts and using canvas layers for the chart to minimize redraws, separating the chart data from interaction, and essentially giving the user a much better experience. There's no flashing. You don't get the sensation that there's any redraws. It's a little bit faster than any of the other HTML5 charts that I've seen. And it's also a YUI module. And we'll talk a little bit more about that right at the very end. So as I said, we're doing this to move away from Flash and maintain the same kind of interactivity and make it faster and make it seem faster for the user as well. And additionally, we're adding spark lines. If anybody's familiar with Tufte's work on spark lines and adding those things and making that simple. It's a very small footprint, and it's all in JavaScript to get away from ActionScript. So what do we get? Spark lines. That's not what they really look like. They're much smaller. Kind of like that. And then the charts essentially look like this. So I wasn't sure if our connection was actually going to work. So I have a real demo. But this is what the charts look like. Just gives you a feel for the stuff that's in there. But let me switch over to a demo. So we have, let me just, this is actually a live demo grabbing our chart data from the finance site. And how does this actually look? Okay, we get all the hover effects. You can see that it's really fast. You don't see any of the redraws. It's fairly dynamic. We can go in and add more chart types. We can get multiple charts on a page as well. So here we have, open, high, low, close, and Bollinger Bands, as well as volume. And the hover does pretty well. And we can go crazy with charts. I don't know how this one's going to look on the screen here, but this has, I think it's 10 charts and about 12,000 points. They come in pretty fast. The hover is also pretty quick, except on Safari for some reason that you'll notice that there's a huge lag between the mouse move and the tracking. I don't know why yet, so I have to look into that. And as well, we have spark lines. So we can look at spark lines for a bunch of different charts. I just have five of them up here for different time periods. So they're all pretty quick. You can make them even smaller. There's a little bit of algorithmic work in there that I do some skipping because there's usually not enough space and you have to draw on a pixel. So until we get sub-pixel on our screen, so there'll have to be something else going on there. But so I do a little bit of skipping when there's too much data. So why is this so cool? We get to use multiple canvas layers and for selective drawing. We don't draw on every canvas layer. We only draw what we need when we need to. So it makes it fast when you're updating legends and hover events. It's very efficient. The most expensive thing is the actual canvas creation. So when I ran performance monitoring on it, canvas creation was by far the most expensive operation. Everything else was very, very fast. And the charts, you only draw the charts once. You don't have to keep track of charts. The charts are just splattered on the page, and you only keep track of legends and the trackball. So it's hover events are like that. So what I create is, essentially all you have is a base layer, a chart layer where the chart is actually drawn, and another layer on top where you do all your changes. All of these are canvases, and they're created dynamically. So all you need is a div, and once you create your chart, the chart knows that it needs to draw the base layer and then 2 canvas layers for every single chart that's on the page. So when you have multiple charts, you'll get, every chart will get those 2 layers on top. So what you saw in the demo where we had all those charts were, I think there were 10 charts, so we saw 21 canvas layers there. And you're only drawing on 10 of those layers. And these are just some of the functions that go into layer management. And this is pretty much all you need for layers. You just need to, create layers, get layers, and remove them. Oh, wrong thing. So just some sample code. You can create the chart with the graph. You initialize the height and the width. You give it a graph type. In this case, this is just for drawing a spark line. Just shows you how easy it is. You add the layer, and you tell it. Oops, sorry. You tell it what data you want to present. In this case, it's a spark line, so it's going to be just the basic quote data, price data, and you draw it. And this is actually, I'm working with the YUI team, the charts team, and converting the canvas to use YUI graphics so that everybody else will be able to use this later. And that's really about it. We're hiring, by the way, in case you didn't know, finance. Sure.
Do you find any big price to pay for using graphics instead of Canvas?
Yes. Is there a big price to pay for using graphics over Canvas? Good question. We're doing the performance measurements on that right now. Is Trip in here? There you are. Okay. So Trip is actually in the YUI team looking at exactly that. So he could probably answer that question better than I can. But yeah, we. But the work that Trip has done is actually it's almost a one-to-one mapping between Canvas and the graphics module, so that we're not actually drawing that many more graphics than canvases.
No, actually, a while back, actually, we have with an earlier version, we did switch out Canvas with graphics, and we didn't have the benchmarks, but the eye test.
Right. Sure. So previously, what Trip just said, previously we did switch out the Canvas modules to test with graphics, and the eye test essentially told us it was pretty good. The performance measurements that I've done so far, just using Canvas, I mean, when we take out those 12,000 points with the 14 charts, or the 10 charts, sorry, I don't think anything is taken more than 85 milliseconds to actually display. So it's pretty quick.
Are you using IE Canvas for older?
Are we using IE Canvas? You mean Flash Canvas?
No, IE Canvas.
Oh, no. No, not yet. We haven't tried. We've done something with Flash Canvas, and it works with Flash Canvas, but not with IE Canvas. Any other questions? Pardon? Oh, no. No, this is strictly done. Sorry, are there any other charts other than finance charts? No, we have the range graphs, open, high, low, close, and area graphs, line charts, dot graphs, and histograms. Pie charts, you have YUI charts for that. So are we planning on deploying this with SVG? So graphics actually takes care of that, right, Trip? So right, so the fallbacks are whatever's appropriate for that device or platform. Any other questions?
Thank you very much.
All right.
Lena.
Thank you.
Okay, next up we have Simon, how do you pronounce your last name?
Hojberg.
Hojberg, with
Yeah.
Thoughtful YUI Development with BDD.
I don't know. Yeah. This really needs some power. What happened? Let me try and... Huh. That is weird. Oh, here we go. Yeah, I have some like weird flashing over my screen, but that's okay. Is that the proper resolution? No. Best for display. Yeah. And where the heck? This is super weird. Let me get this guy back. Yeah. I guess this is the joy of the new Macs. Yeah. I mean, I don't need to show this at all.
Did you click arrangement here?
What the heck?
Can you click on this one right here? Click arrangement. Maybe we can get it to nearer than. There you go. So that'll help your scroll.
Yeah. Okay.
Try
So
going back to
Keynote
display again.
broke.
One more time. Display right there. The other window. Click display.
This for external monitor, I guess. 60 hertz, like you said. Oops. That's not what I wanted. Okay. Arrangement, I think we're getting there. Keynote. Still kind of cut off, right? Yeah. Where'd the other guy go? I guess this is almost okay. We'll go with that. Yeah, so I'm Simon with Swipely, and I'm going to tell you a little bit about BDD. So BDD stands for Behavior-Driven Development. It is an evolution over test-driven development, and it is a way to describe your product that write your test so that you describe your product specifications and verify that with your code instead of just writing tests that are very specific to your actual code. So it's a way to be very focused on your product. So it's widely adopted by various other communities, and I think we should get a piece of that pie too. So the core principles of the takeaway I want you to get from this talk is when you do BDD, always start by describing a behavior. I'll show you in a second how that looks. Get a red test, then build that behavior and get a green test. BDD is a two-prong system where there's acceptance testing and unit testing. I'm not going to talk about acceptance testing. We don't have that time, but I'd love to talk to you about that in the hall after or something. So yeah, unit testing. So, sweet animation. And it skipped to the next slide as well. Wow. Okay. So we're currently building something called Primrose, which is a BDD framework for YUI, soon on the gallery. And I'm going to talk to Dave and Reed to hopefully get it to be buildable with both Yogi and Yeti. And it is very much inspired by Jasmine and RSpec. And basically, this is for building your unit tests. So we're going to dig into an example of a Primrose spec. They're called specs, not unit tests. That is not good. Maybe if I don't. Yeah, so okay, this is going to be really awkward, but hopefully you can read that. So I'm describing the Millennium Falcon's hyperdrive, and there's a bunch of stuff underneath, and we're going to dig into these individual. Basically, this is a unit test for the hyperdrive of the Millennium Falcon. So we're going to dig into this before each block, and this is essentially your setup block, just like you had in YUI test. And for that, we instantiate our hyperdrive, set it as the subject, so that it's available for the individual tests to assert behavior. Then we're going to describe a behavior, which is it works when punched. And we are going to run the method punch on subject, which is the hyperdrive that we just defined, and assert that it is operational now. Mind you, we haven't built that punch method at all yet. We're just architecting our API. And we're going to do the same with this bottom one. And yeah, that's basically the same. We're going to build a jump method and expect that the speed is now faster than light. And yes, and then this is the full thing. I hope you can read it because this is kind of, yeah, that makes sense. This is the full spec of the hyperdrive, and once we've done this, we can now go ahead and start building code. So we'll get a red, maybe I can go full screen again. We can get a red test, make that go green, do our code, and that is basically it. This will be available on the gallery shortly, hopefully tomorrow when I learn how to do gallery modules from that other talk, which is going to be awesome. I can't wait. And again, this is the principle. Always start by describing behavior, get a red test, build that behavior, get a green test. The reason why you're doing BDD is to verify that your product specifications are met. And yeah, thanks. I'm Simon. Any questions?
Thank you very much.
Yeah?
What are the main differences between Primrose and the YUI test module?
Oh, there are a lot of differences. Essentially, it's well, apart from the API, of course, it's a whole nother way of thinking of how you test, because you are verifying your product specification. You can write BDD with YUI test, but it does not look pretty. I have done so. Yeah, it's basically just a series of nice APIs that make sense in the BDD world, which is modeled after our spec, which is created by the creator of BDD, Dan North. Yeah. Does that answer your question?
Yes.
Thanks. Anyone else?
We have one more message. Thank you so much.
Thanks.
Hey guys, before we break out for hors d'oeuvres, I just have another announcement. We're recruiting still here, and nothing much has changed since 1 o'clock, except I've gotten bigger with all the food. But before we go on, today's hors d'oeuvres is brought to you by our search department. And search has openings, but instead of taking my word for it, I want to introduce you one of our stars of search. You guys have followed him on Twitter, his blog. He's like a superstar, and we're really excited to have him here at Yahoo for the last year. And he's going to tell you a little about search. So let's give it up for Mr. Patino. And thank you for sponsoring hors d'oeuvres tonight.
All right. I have been at Yahoo for almost 5 years. I almost started with Dave. In the last 3 years, I've been working at Search, where we actually get to touch the life of millions of people just by doing YUI and creating YUI components. So during the last year or so, we decided to shift the whole infrastructure to use a new front-end platform, to use a new set of layers for the front-end layers, all the boxes that receive traffic and all that. And we decided to go with Node and with YUI running on those boxes. So now we have been, for the last year or so, doing YUI from the server to the client all day long. And it has been awesome for us. And we are looking for people that can actually do that, and from time to time get a ping from Dave Glass at midnight showing you some crazy stuff that he just get done for us to make it into this pipeline of YUI infrastructure that we have created for search. So if you guys have any questions, we are hiring a bunch of people right now. So just talk to me or talk to Cham or anyone from Yahoo. We have a bunch of people from search today as well. So that's pretty much it. Thank you.